Hello, my name is Elif Eskioğlu. I'm the team leader of one of the 2025 senior design projects titled DEXO, the Hand Exerciser. Today as Group 24, we are proud to present the final report of our project. As you can see on the screen, my team consists of myself and three fellow engineering students. Büşra, Sema, Akgün has served as the system engineer and Hülya Karagülle has taken on the role of hardware engineer. I, on the other hand, I am both the team leader and the person responsible for the software side of the system.
Hi, I am Hülya Karagülle. I am hardware engineer. Today, I want to tell you about DEXO, a project we developed as a team. DEXO is a special glove made for people who cannot move their hands well because of stroke or other health problems. Most normal rehab devices are expensive, hard, and need to be used with a doctor. But our glove is soft, light, and easy to use by yourself. The most important thing users need the glove that helps their hands move again in a comfortable and easy way. People want a glove that's strong enough to move their fingers, but also light, so they can wear it for a long time. With DEXO, we give users comfort and freedom. Some eye problems make it hard for people to use their hands by themselves. Normal therapy is expensive, takes a lot of time, and you always need a therapist. But DEXO is soft, easy to use, and made here. It is also much cheaper. What makes DEXO special? Traditional rehab device for clinical use only. High cost and uncomfortable. DEXO can be used home or clinics. Low cost, it's soft and ergonomic. For DEXO, we sent some important requirements to make sure the glove is safe, easy to use, and helpful for users. Firstly, engineering requirements. Each therapy section must last at least 15 minutes. User can change the speed and power of the glove as they wish. There is an easy on-off button on the control box. For marketing requirements, the glove helps users move their fingers with different pressure levels. It is light, so you can wear it for a long time without getting tired. The glove can be used at home or clinic. In summary, DEXO is made to save, comfortable and simple for everyone to use. At home, at clinic, anywhere you want.
Hi again. In this slide, you see a block diagram summarizing our design's implementation details across three layers. Our primary goal is to present a clear visualization of how hardware and software components share responsibilities and exchange data. Here, the full system block diagram is shown in greater detail. From top to bottom, you can identify the user interface, the control layer, and the pneumatic actuation layer. I'll now discuss the function of each of these layers in turn. The user interface layer comprises two main elements. On the left, 5 tactile push buttons, and on the right, a 16 by 2 I2 driven LCD. The buttons handle parameter input, while the display provides the feedback and status messages. The hardware portion of the control layer includes the microcontroller board and hush-bridge driver, and opto-isolated relay modules. These drivers manage the pump and valve coils, handling all direction and power switching. On the firmware side, 4 core functions are implemented: update interval, update speed, process start-stop, and blow-suck cycle. These modules operate under a finite state machine structure to ensure deterministic and safe system behavior. Our final layer is a pneumatic actuation layer. The diaphragm pump works with sync with the pressure and the vacuum valves to open and close the glove. The airflow generated here and produces the patient's rehabilitative opening and closing motion. We run the system clock at 4 MHz, giving timer 1 clock of 1 MHz. By setting auto-reload register to 99, we achieve 100 discrete pulse width modulation steps. For example, a 25% duty cycle uses compare register 1 equal to 25 and full 100% uses compare register 1 equal to 99. This table shows PWM and I/O pins assigned to each function on the microcontroller. Also, I2C bus uses PB7 for SDA and PB6 for SCL in 100 kHz standard mode to communicate with the display. For safety and compliance, we employ IAC 610.1 complete opto-isolation, ISO 13849-1 Category B emergency stop, and MSRA-C coding guidelines. This ensures protection for both the patient and the system. Now we move into the testing and demonstration section. Our test plan consists of 4 levels: unit, module, integration, and acceptance tests. Each level verifies how well our design meets the requirements. In this slide, you can see that the update interval function correctly updates within the 4 to 7 second range, and the update speed function successfully adjusts the PWM duty in 25% steps. And in this slide reports that the PWM output achieves 10 kHz plus or minus 1% accuracy on the oscilloscope, while relays switch in under 20 milliseconds, and display shows TEST without any flicker.
Hello everyone, I am Büşra Sema Akgün. I will start with integration test results. Our prototype successfully passed integration testing, showing smooth cooperation between hardware and software. 10 full inflation-deflation cycles were completed with less than -4 plus 5% timing error and full wave synchronization. During acceptance testing, 25 participants operated the device with no issues and adjusted settings easily. The device met both engineering and marketing requirements. It runs on 220 voltage, has fixed session timing, and allows easy adjustment of pressure and cycle duration. Key features like the user interface, LCD screen, and opto-isolated safety relays performed well. Core functions such as finger motion support, session customization, and user safety were verified. Total prototype cost was only 3,387 Turkish lira. Major expenses included the SEM32 board, motor driver, valves, and LCD display. All assembly was done in-house and we used open source software, avoiding licensing and labor costs, cutting nearly 50% from our original 6,850 Turkish lira estimates. The design shows strong commercialization potential. Its low-cost modular structure and user-friendly interface make it suitable for home use by stroke survivors or patients with neuromuscular conditions. We followed key safety and medical standards including ISO 13485, IEC 6061, and ISO 13849-1. Low voltage components and isolated control support compliance with CE and national medical approvals. For safety, a dedicated start-stop button shuts down all outputs instantly in case of a fault. The system enters a safe state. High current parts are electrically isolated, and pressure levels remain within safe physiological limits. Thank you all for your attention.